Hi everyone, my name is Lucas and my project is entitled Statistical Analysis and Modeling of the 2013 Brazilian Survey focused on aging. So first of all, let's start with some characteristics of the dataset. It was a text file that I obtained from the Brazilian Institute of Geography and Statistics. It's a governmental institution and you can go to the website to get all the files. So it was a little bit hard to interpret. So this is what the file looks like, of a bunch of numbers and a bunch of lines. So it was a little bit hard to interpret because all the responses and the variables are coded, and since it's not a CSV file, the widths of each variable were fixed. So this is the other file that was available on the website, and basically the first column is a starting column of the variable name and the length. So I had to, when pre-processing the data, I had to first read that file with all the starting columns and the lengths of each variable, and then use some regular expressions to transform all these numbers into some meaningful responses. Also, the text file was really large, so it was taking some time to read in RStudio, so I had to use the package readr from the Tidyverse, which made things much faster. And also, since there are 942 questions in this questionnaire, there were a lot of not available data points, and there was not even a single person who responded to every single question out of the 200 and something thousand observations. So I had to create a function to get rid of the NAs for the questions that I was looking specifically at. So there was also an Excel file with the code of the variable, its meaning, with the code of the variable, the initial position, the size, the length, the responses, the code of the responses, and what they actually mean. All this file was in Portuguese, but that was basically it. So I had to go from RStudio to this file a bunch of times to try to make sense of what the responses and the variables meant. So after pre-processing the data, I started analyzing the data. So I had some questions related with aging and chronic diseases about this data set. So I was trying to analyze if age had an effect in chronic diseases, and also if it was possible to make some models that we learned in class to predict some acute events. And after that, the last part of this analysis was basically trying to use some of the questions from the questionnaire to predict a person's age without having to use any laboratory information. So starting with aging and diabetes, this was the most marked age-related effect of all the chronic diseases. So in the first figure, we can look at the histogram of people with diabetes, and in this figure, people without diabetes. We can see that here it peaks at 30-40 years, and here around 67. And using Pearson's correlation coefficient in the package header correlation in R, we can get the correlation coefficient for categorical and continuous variables, for the comparison of categorical and continuous variables. It was 0.245, which is a reasonable correlation. And then I tried to fit some models to predict diabetic coma, which is a very dangerous life-threatening event associated with diabetes. The k-nearest neighbor model wasn't performing that well. I used the kappa values as my main parameter, since the accuracy was going to be high if the model simply predicted that no one had diabetic coma, because it's such a rare event. So kappa was my main predictor for all the models. Random forest was a little bit better, but not too much, and support vector machine same. We can see here in this graph, looking at a person's age and how long ago that person was diagnosed with diabetes, that the model simply guessed that no one had diabetic coma. And also, using a gradient boosting model and the summary function, and also a generalized linear model and the coefficients, we can get a sense of what the important variables in predicting the diabetic coma are. And the first one is how long ago the person was diagnosed with diabetes, and the second one is a person's age. So you can see there is a very marked influence of age in predicting diabetic coma. And here it's analyzed more in depth in the report, but we can also get how much each variable in each response meant for the final predictor. Then I went on to trying to predict cerebrovascular accident caused by diabetes, and again, the K-nearest neighbor model was not that good. The last one had a cup value of 0.07, which is better than 0, and relative force was pretty decent compared to just random guessing, with some kappa values of around 0.15, 0.19. Also, we can do the same thing with the gradient boosting model and the generalized linear model to get the predictors. And again, C008 was how long ago the person was diagnosed with, is a person's age, and this one is how long ago a person was diagnosed with diabetes. And in the report I talk more about the others. Then I move on to look at the relation between aging and cardiovascular disease. And here, looking at the two graphs, not diagnosed with the cardiovascular disease and diagnosed with cardiovascular disease, we can see a very marked age-related effect, and the coefficient was 0.175. And then, this is just an aside, but I also looked at how high cholesterol and cardiovascular, for people with cardiovascular disease, change with age. So 1 means high cholesterol and 2 means normal cholesterol. And we can see that the people who have cardiovascular disease have a higher percentage of high cholesterol, close to 50 to 70 years old, and close to 10 and 30. There are not that many people with CVD and high cholesterol, and same for the higher ages. And 30% of people with CVD had high cholesterol overall. So, trying to predict cardiovascular disease with some of the questions, the random forest model did not do that well, and the K-nearest neighbor also did not do that well with the questions I selected. And we can see the relative importance using the gradient boosting model. So, age was the most important one, and then I talk more about the other ones in the final report. Depression aging also had a very minor correlation. There is some correlation, but it's not as apparent as the other ones. Same with arthritis. This was basically the same. The two histograms look basically the same, but not that many people responded to this question, as we can see by the count number. So this is not very representative of the population. For spinal problems and aging, there was a perceptible age-related effect. And so I tried to predict how much spinal problems affect daily life. It was scaled from 1 to 5, and 1 affects a lot, and 5 not at all. And the random forest, the best one, had a kappa of 0.10, and the current K-nearest neighbor did not fare that well, with even negative kappa values. And also, out of the important variables, age is the most important one, and I talk about the others in the report. Finally, I tried to predict aging based on the questionnaire. I used the XG boosting model since it handles not available data really well, so I basically use all the questions besides a person's age, and surprisingly, I was able to get a perfect fit in a root square mean error of 0.07, which is basically nothing, so something was wrong, and the accuracy was at 99.9%. And then looking at the data set, I realized that not only there was a question regarding a person's age, but it was also when the person was born, so that's why I was getting a perfect fit. So I changed that and removed that question, and this is the final model that I got after tuning the hyperparameters for a little bit. And we can see that it's a reasonable model with the predicted values around the actual values. And we can also see stages because some questions were targeting specific groups of people, such as married people, people that were retired. So those were the primary predictors of a person's age, and it was not anything health related or related to social determinants of health, unfortunately. So overall, we can see that age and chronic diseases are related for most of the time, not with depression and arthritis, but with diabetes, cardiovascular disease, and spinal problems. Most of the models do not fare that well, but I had to select some of the questions that I thought were important firsthand. Since if I selected all of them, there would be no data available, since there were a lot of NAs. So I talk about it a little bit more in the report. And about predicting aging, it's possible, but most of the relevant predictors are not that relevant to healthcare. Okay, so this is my final project, and thank you.